Welcome to your Algebra 2, Lesson 7.6 video. Today you will learn to solve exponential and logarithmic equations. So that's the objective, to be able to solve exponential and logarithmic equations. Okay, an exponential equation is an equation in which variable expressions occur as exponents. So you have to have a variable as an exponent. Logarithmic equation is an equation that involves logarithms of variable expressions. So you have to be taking the log of something with a variable. Property of equality for exponential equations. And we've kind of worked with this already. If b is a positive number other than 1, then b to the x equals b to the y if and only if x equals y. So for example, if 5 to the x equals 5 to the 4th power, then x equals 4. If x equals 4, then 5 to the x equals 5 to the 4th power. So if you can get the same base on both sides, you can set the exponents equal to each other. Okay, so we call this solving by equating exponents, okay? All right, so I've got 4 to the x equals 1/2 to the x minus 3. Now I know 4 is 2 squared and 1/2 is 2 to the negative 1, so I'm going to write both sides of this equation as powers of 2. Okay, so 4 is 2 squared, so 4 to the x is equivalent to 2 squared to the x power. 1/2 is the same thing as 2 to the negative 1, so I'm going to re-express it as 2 to the negative 1, and I still am going to raise it to the x minus 3 power. Now I'm going to use the power of a power property and rewrite this as 2 to the 2x equals 2 to the negative x plus 3. I just multiplied that negative 1 times the x minus 3. Okay, so now I've got two power expressions with the same base, and so I can set my exponents equal to each other. So that's going to give me 2x equals negative x plus 3. So I'm going to solve for x. So let's see. I'm going to add x to both sides. That's going to give me 3x equals 3. Divide by 3, and that gives me x equals 1. So let's check. We're going to substitute 1 in for x. So we want to know 4 to the first equals 1/2 to the 1 minus 3 power. So I get 4 to the first is just 4. 1/2 to the negative 2 power. I flip that 1/2 to become a 2. 2 squared is 4. So the solution checks. So 1 is our solution. Now, what happens when you can't write both sides of the equation as a power of the same base? Well, we've got another method for that. When it is not convenient to write each side of an exponential equation using the same base, you can solve the equation by taking a logarithm of each side. Okay, so we want to solve 4 to the x equals 11. We're going to write the original equation. Now, we've got 4 to the x. Whenever we try to undo something, we use the inverse. So what's the inverse of 4 to the x power? It is taking the base 4 logarithm. That is the inverse of doing 4 to the power of x. So we're going to do the base 4 logarithm of 4 to the x equals the base 4 logarithm of 11, because whatever we do to one side, we have to do to the other. Okay, well here we've applied an inverse, so the base 4 logarithm and then the 4 to the x, the 4's cancel each other out. The base b logarithm of b to the x is x, so the base 4 logarithm of 4 to the x is x. So x equals log base 4 of 11. So on our cool CAS calculators, we can enter that in directly. But for most calculators, you'd have to use the change of base formula and do common log of 11 divided by common log of 4 or natural log of 11 divided by natural log of 4. Either way is fine with me. Rounding to the nearest hundredth, you would get 1.73. If you want to check, you can plug it back into the original equation. Remember, we rounded there, so your answer should round to be 11. Property of equality for logarithmic equations. If b, x, and y are positive numbers with b not equal to 1, then the logarithm base b of x is equal to the logarithm base b of y if and only if x equals y. So if you have the same kind of log on both sides of the equation, just one logarithm, you can set the anti-logarithms equal to each other. So if we have log base 3 of x equals log base 3 of 8, see, we're taking the same kind of log, of both sides, so we can just set the x equal to the 8. Then x equals 8. So if x equals 8, then the log base 3 of x is equal to log base 3 of 8. Always check your answers when using a logarithmic equation. Look out for extraneous solutions. Okay, so we've got log base 5 of 4x minus 7 equals log base 5 of x plus 5. Okay, so looking at this, we're taking the same kind of logarithm on both sides, so we can just set the 4x minus 7 equal to the x plus 5. All right, so subtract x and add 7, and you get 3x equals 12. Divide by 3, and you get x equals 4. Okay, we do need to check this. So wherever we have x, we're going to plug in 4. So we want to know if the log base 5 of 4 times 4 minus 7 is equal to the log base 5 of the sum of 4 plus 5. So 16 minus 7 is 9, 4 plus 5 is 9, so we have the log base 5 of 9 equals log base 5 of 9. Solution checks. All right, sometimes we need another method, and we call this exponentiating to solve equations. Okay, that's exponentiating. If you are given an equation x equals y, then you can exponentiate each side to obtain an equation of the form b to the x equals b to the y. This technique can be useful for solving logarithmic equations. Okay, so we're going to solve and we're going to exponentiate both sides of an equation. So we've got the base 4 logarithm, or log base 4 of 5x minus 1, and the whole thing equals 3. Okay, so on this one, we don't have the same kind of logarithm on both sides of the equation. We don't have any kind of logarithm on the right. So this is a case where we are going to exponentiate. Now, the key here is that you exponentiate with a base that matches the base of your logarithm, so they'll cancel out. So since I'm doing a base 4 logarithm, I want to exponentiate each side using base 4. So I'm going to have 4 to the power of log base 4 of 5x minus 1 equals 4 to the third. Okay, so both sides of the equations pop up as exponents with a base of 4. On the left-hand side, 4 to the power of and base 4 logarithm of cancel out. So we're left with 5x minus 1 equals 4 to the third power is 64. We add 1 to both sides, divide by 5, and we get x equals 13. Okay, we need to check this. So what are we going to do? That's right, we're going to plug in 13 for x. All right, so we're going to see that the log base 4 of 5 times 13 minus 1 equals 3. And they're just simplifying that left-hand side here. Okay, so log base 4 of 5 times 13 minus 1, 5 times 13 is 65, minus 1 is 64. So we've got the log base 4 of 64. 64 is 4 to the third power, so that simplifies to be 3. And so our solution checks. All right, standardized test practice. What is or are the solutions of common log of 2x plus common log of x minus 5 equals 2? All right, we're going to write the original equation. Now to use either method, whether we're going to equate logarithms or we are going to exponentiate both sides, we have to have single logarithms on either side of the equation. So we need to condense common log of 2x plus common log of x minus 5. So that's going to give us common log of the product 2x times x minus 5. That equals 2. So now we're going to exponentiate each side using a base of 10. So we're going to have 10 to the power of the common log of the product of 2x times x minus 5 equals 10 squared, because we're raising up both sides as powers of 10. Now on the left, 10 to the power of and taking the common log of are inverse functions, so we're going to end up with just 2x times x minus 5 equals 10 squared, which is 100. So 2x squared minus 10x equals 100. What did I do there? Let's go back and look. I just distributed the 2x. We're going to write this in standard form so we can solve it. So 2x squared minus 10x minus 100 equals 0. We can divide both sides by 2 just to make our life easier. So we've got x squared minus 5x minus 50 equals 0 divided by 2 is just 0. So now we're going to factor. You could use quadratic formula, that would be fine too. But this one's pretty easy to factor. It factors to be x minus 10 times x plus 5 equals 0. So we're going to use the zero product property, and we set each factor equal to 0. X minus 10 equals 0 gives us x equals 10. X plus 5 equals 0 gives us x equals negative 5. Now, to check, we're going to substitute 10 and negative 5 for x in the original equation. So let's do 10 first. So we have the common log of 2 times 10 plus the common log of 10 minus 5 equals 2. 2 times 10 is 20, 10 minus 5 is 5. So we've got common log of 20 plus common log of 5 equals 2. All right, so if I condense this, which I need to, what I'm going to do is I'm going to multiply the 20 times the 5. So I have common log of 20 times 5, so common log of 100 equals 2. Well, the power of 10 that gives us 100 is 2, so 2 equals 2. That solution checks. So let's try negative 5. So that's going to give us common log of 2 times negative 5 plus common log of negative 5 minus 5 equals 2. So that gives us common log of negative 10 plus common log of negative 10 equals 2, but we can't take a logarithm of a negative value. So because common log of negative 10 is not defined, negative 5 is not a solution. It is an extraneous solution. So 10 is the only solution, so the correct answer is C. Okay, guys, thanks again to Larson Algebra 2 by Hope McDougall. That is my source in my textbook. Please do your practice problems and come to class ready to do your rounds. I will see you soon. Bye.